So this is going to be page 2 of the study guide. Problem 6 and problem 7, the directions are the same as 4 and 5. So it's find your domain restrictions and solve the equation. So for problem number 6, I want to focus on just my domain restrictions first. Well, I only have one denominator right now, which is kind of nice. So I'm going to set that denominator equal to 0, and that's my domain restriction. So my domain restriction in this case is n cannot equal 0. All right, that's the only thing I have to worry about. LCD, least common denominator. That one's actually going to be relatively easy as well because you only have one factor in the denominator, which is the letter n. It's the variable n. So what I'm going to do is take every part of my equation and multiply it by n. So in my first part here, I guess, we've got n times n. So that's going to turn into n squared. In the second part, this n will divide out with that LCD. So all that's left is plus 16. And then over here, right, I've got equals 17 times n, so 17n. This is a quadratic, so I'm going to go ahead and subtract 17n from both sides so I can get one side equal to 0. Now I'm going to factor this. So I'm looking for what multiplies to positive 16 and adds up to negative 17. Well, the only way to multiply to a positive and add to a negative is if both of your numbers are negative. So if I go with 16 and 1, negative 16 times negative 1 is positive 16. Negative 16 minus 1 is negative 17. So now that I've got my factors, I'm going to set each factor equal to 0. And now let's see, I've got n equals 16, n equals 1. Quick double check, neither one of these is my domain restriction. So both of these are possible answers for this problem. So I identified my domain restrictions, n cannot equal 0, and I have solved n is equal to 16, n is equal to 1. Both of these answers work. Let's go ahead and slide over to number 7 and do the same thing. So number 7, I want to focus on my domain restrictions first. So I've got c squared minus 4, but that's actually duplicated, so that's kind of nice. And I have a separate factor of c plus 2. So if I take c squared minus 4 equals 0, I'm going to factor c squared minus 4, so c minus 2, c plus 2 equals 0. So set each factor equal to 0. So c equals 2, c equals negative 2. Now, if you wanted to, you could set c plus 2 equal to 0 as well, or if you recognize you've already done that right here, c plus 2 equals 0, you don't have to repeat it. So domain restrictions, c cannot equal 2 or negative 2. All right, so those are my two domain restrictions. LCD, let's get the L first. All right, LCD. So if I look at my factors here, this is c minus 2, c plus 2. I already have c plus 2 here, and then this is a duplicate of c minus 2, c plus 2. So if I look at my LCD, I have the factor of c minus 2, which would take care of this factor and that factor. And if I do c plus 2, that takes care of that piece, and that piece. So every part of my denominator is now taken care of with this LCD. So I'm going to take that LCD and multiply it times all of the pieces of my equation. And let's make sure I get it all in the right place. And I'm writing it correctly. c minus 2, c plus 2. All right. Let's see what we can divide out. So in the first fraction, c minus 2 and c minus 2 will divide. C plus 2 and c plus 2 will divide. So this is completely gone. All that's left is 1. And that number 1 is from this numerator. So plus c plus 2 will take out c plus 2. We'll divide it out. So I'm left with 1 times c minus 2 equals C minus 2 will divide out C minus 2. C plus 2 will divide out C plus 2. So all that's left is the number 3. All right, let's clean this up and see what we get. So we've got 1 plus, if I distribute 1, that's still C minus 2 equals 3. All right, so if I clean up the left side here, so it's going to be C minus 1 equals 3. 1 minus 2 is negative 1. All right, so I'm going to add 1 to both sides. So C equals 4. Quick double check, C equals 4 is not one of my domain restrictions. So there's my answer. My domain restrictions are off to the side. So problem number 7 is done. All right, I'm going to go ahead and slide on down to number 8 here. Describe the transformations on that graph given that transformed equation. All right, so I color code this just for giggles. I've got a minus 5 here attached to x, and I have a plus 8 here attached to the fraction. So anything that's directly attached to x is going to be some kind of a horizontal change. So horizontal, in this case, we're going to do a horizontal translation, which you guys might think of it as a shift. Now, it says minus 5. Because it's directly attached to x, that's actually going to be moving to the right 5 units. It's kind of opposite of what you think it would be. And then that plus 8 is attached to the fraction. So that's going to be a vertical translation. And that's up 8 units. All right, so problem number 8, those were the only transformations. So number 8 is now done. Let me go ahead and slide over to number 9. Again, we're looking for identifying transformations. So I've got a transformation of 2 here, a plus 7 here, and a minus 4 here. All right, so that positive 2 in the numerator is a vertical stretch by 2. You're basically taking your entire function and you're multiplying it, all its values by 2, which is going to stretch it further away from the x-axis. A plus 7 in the denominator with the x, that's a horizontal translation. So horizontal translation. Because it's plus, it's actually going to be going to the left 7 units. It's kind of weird, it's kind of backwards, but we work with it. And then minus 4 is being subtracted from, or is being attached to the entire fraction. So those are your vertical translations. Vertical translation. And that one's pretty straightforward. It says minus, it's going to be moving down 4. All right, problem number 9 is done. Let's see what number 10 has in store for us. Still working with your transformations. So let's see, we've got f of x graphed. Use transformations to graph and label the transform functions. Okay, so it's not required, but I highly recommend that you make a note to yourself so that you know that this plus 2 attached to x is going to move you left 2 units. And this minus 1 is going to move you down 1 unit. Okay. Now, in the original function, I'm going to put these in blue to kind of match the blue curve that I've already got here. There is a vertical asymptote here and a horizontal asymptote right here. Those are what I'm going to move, all right? And I'm going to change colors. I'll go with this bright pink color here. So this vertical asymptote, I'm going to shift left 2. So there's my new asymptote. And this horizontal asymptote, I'm going to shift down 1. So now my curve is going to sit in this lower left corner, and the curve is going to sit in this upper right corner. So if I keep with the same color scheme-ish, it doesn't matter if you color code these or not, it just kind of helps, at least for my brain it does. So there's the lower left. And now let's hit the upper right here. So right there. And it does say to label it. So I'm going to go ahead and label this K of X. And this way it's in the same color as the new curve. So we've shifted it. Now, Part B says to determine the y-intercept. Now, I clearly see that this curve crosses the y-axis. I kind of have a guess that it might be at negative 0.5, but I don't really want to guess with it. So I'm going to mathematically figure out that intercept. If I remember that a y-intercept always has an x value of 0, I can replace x with 0 and solve the problem that way. So 1/2 minus 1, yes, that is in fact negative 1/2 or negative 0.5. So there's my y-intercept. All right, so that's problem number 10, all nice and done. Make sure that you can do that with your transformations, please and thank you. I'm going to slide over to number 11. Let's see, number 11, use transformations to graph and label the transformed function. List each key feature of the transform function. Yeah, I said it right. All right, so 2 transformations here, a -3 here, a +2 here. So this is going to be right 3, up 2. So if I put in the original asymptotes, those are just to kind of help me get an idea where my curve goes. This is where I'm going to move these. Okay, so the new asymptote, I'll do these, I'll go with purple, I guess. It doesn't matter. So to the right, 3, and then up 2 units. So there's my new asymptotes, and that's going to put my new curve in this upper right-hand corner and the lower left down here. I believe I'm supposed to label it. Of course I'm supposed to label it. So let's call this g of x right here. All right. Now I'm going to do things a little out of order with the key features. I'm actually going to identify the asymptotes first. So this vertical asymptote is at +3 right here. So this is x equals 3. And this horizontal asymptote is at +2, so y equals 2. The reason I do these is because this vertical asymptote is the value I have to throw out of my domain. So my domain is going to be from -infinity to 3, and then from 3 to infinity. And this value for my horizontal asymptote is what I need to throw out of my range. So range is going to be from -infinity to 2, and then from 2 to infinity. This little union symbol, it's a little U shape. It's not actually a letter U, but it's a U shape. It just means that we're joining these two pieces together. All right, so I believe that takes care of, yep, that's the end of page 2. Please ask any questions that you have about these problems before the test. Contact me through Canvas, contact me through email, pop into the Zoom meetings, ask anything that